Good morning, friends. To continue our lecture on the key issues in BOPP tape manufacture, the remedies, let us continue part 2. Accuracy of coating heads. Uniformity of the nip or the gap between the coating rolls. The dynamic balancing of the coating rolls. Surface evenness of the coating rolls contribute to the good quality of final product. Here it is a photograph which can show you what it means. There are a few more photographs here. If the alignment is not proper, this is how the film will behave. You can see there are lot many stretches. The film is not uniform, and this is going to cause a lot of problems in processing further. Ability to handle various substrates. You see the kind of winding here. This is not a really acceptable one. Whereas in the photograph number 2, this is the best kind of uh, winding. It's called as square winding. Even the photograph number 3 also shows that the winding is very good, very square. Here it is a photograph of a laminate of golden metallized film with silicone paper. The benefit of square winding is you can control the trim losses to its minimum. The ideal trim width could be around 5 millimeters on both the sides, and this is possible if and only if the winding is square. High percentage of seconds quality or rejected quality. What is the reason and how we can correct it? The main reason for high percentage of seconds is poor quality of coating, old-fashioned mechanical clutches, hence all tension setting is manual and the same is operator oriented. Third reason is loose or tight winding. The fourth one is uneven diameter of coated roll across the width. Poor roll formation, too tight or too loose or telescopic. You can find a photograph here. This is how a tight winding could result into paper core collapse, and this gives rise to lot many problems while converting this parent roll into small rolls, rewind and slit rolls. The area where the core has collapsed, the balancing of the coated roll is goes out of control, and you get a kind of jerk every time the roll is near to the dent, and this causes lot many problems while slitting. Unprofessional tension control is one of the reasons. All manual adjustments, these lead to a particular person oriented. The tension set by a operator in a shift may vary in the second or the next shift, and this gives rise to a lot of human error and results into poor winding. Variation in setting person to person. High percentage of wastage. You can see a photograph here where The winding is not at all square, but it can be termed as telescope or shifted. Uneven coating thickness across the width is the main reason. Poor or no material handling equipment is the another reason. Manual adhesive charging is one more reason for high wastage. Manual rule unloading or loading. Adhesive voids and sticks. What are the reasons? How we can correct them? Poor wetting of adhesive due to dilution with water. In case of water-based adhesives, one should try and avoid dilution of adhesive with extra water to adjust the coat weight. The right approach will be to change the Meyer bar or to change the Grevia cylinder. It is bit time consuming, but we can save a lot on the final quality of the product. Many times the additional water which is used is hard water or the tap water, and this gives rise to lot many problems like adhesive voids, uncoated patches, streaks, because we all know hard water contains lot of dissolved salts. These salts they precipitate after the water is evaporated and they give rise to spots or voids in the coated film. Adhesive contamination with dust, foreign particles. The reason for this is poor shop floor or poor housekeeping. Dust collection on film could be due to static electricity. We all know when a plastic film moves on several rolls, a lot of static electricity is generated. The static electricity forms a magnetic field around that particular area or across the width or along with the width, and this magnetic field attracts the dust from the shop floor and it creates lot many adhesive voids or sticks. Contamination of dust in hot blown area. Now in case if the hot air blowing equipment like hot air generator or uh, thermopack or any other kind of heating system, if it is installed in open air outside the premises, the chances that it can collect a lot of dust from the atmosphere and it can spoil a good product. Rusty nozzles or air ductings. Many times the hot air carrying ductings are fabricated out of galvanized steel or mild steel with no protection or no surface coating. And as time goes, if the plant is situated in areas like coastal areas where humidity is high and the air is salty, it results into rusting of the surfaces inside and it gives rise to lot of rust or dust in small particle size. As the time goes on, this rust gets delaminated from the surface and is easily gets contaminated with the hot air blown inside. Another major reason for air voids or air bubbles is foaming. We all know that the adhesive in the tree is continuously generating foam because of the revolution of the Greville rule. So it is prime importance that the foam generation should be avoided. This can be done by charging adhesive from the bottom of the tray, maintaining minimum level of adhesive in the tray, avoid dilution of the adhesive by adding extra water for adjusting the coating weight. For adhesive coat weight adjustment, use alternate Meyer bars or crevice cylinder of lower wide diameter or lower cell structure. Dilution of adhesive with water is not a right method for controlling the adhesive coat weight. Maintaining a proper level of adhesive in coating tree is very important. How we can do it? Handling of adhesive. Here is an cost-effective alternative to expensive adhesive pumps like double diaphragm pumps. You just need air compressor, maybe 3 HP capacity, a air compressor line. The rest you can do it yourselves. How? Have a look at this figure. The adhesive drum, the one outlet can be opened and a PVC pipe with fair thickness can be inserted into that, and you can follow this diagram and you can control the adhesive level in the tray. This system will also help you to control the manpower. You don't need a dedicated person or operator to add adhesive time and again, but it can be controlled by controlling the air walls or the air pressure, and the adhesive can be pumped into the tray as per the requirement of the coating station. Maintain minimum level of adhesive in the tray. This will help indirectly to control the foam. More the quantity of adhesive, more are the chances of foam generation. Here you can see the tray size which is shown in gray color. You try and maintain a adhesive level so that the gravy roll is dipping approximately 50 to 20 millimeters so that the quantity of adhesive will be controlled. This is the right way charging the adhesive level in the tray size. All these steps they help in minimizing the foam and the wastage thereafter. General mistakes or practices followed in the industry are too high adhesive level in the tray, very big tray size, results creating maximum foam and wastage. Charging of adhesive from the top is another mistake which one should avoid. There are many BOPP manufacturers where I have seen the adhesive is charged this way. The adhesive is taken from the barrel to a bucket. From the bucket, the adhesive is taken in plastic mugs. Then the adhesive is charged into the tray from top. This also adversely affects the quality of the coating, like it generates lot of foam. This should be avoided. It will help in eliminating a requirement of one operator just meant for charging adhesive. How this is possible? How is the foam destructive? This will wipe off your profits due to huge wastage of adhesive, creates pinholes, craters, uncoated patches. The foam generated will cause a problem like pinholes. This is how you can see the quantity of foam generated in the drum if the adhesive is not handled properly. This is how the uncoated lines are created due to particles and foam in the adhesive. Film gauge variation also is responsible for uncoated lines. The area where the film thickness is high will not get any adhesive coated and will result into uncoated patches. It is not visible to a great extent as far as the adhesive is transparent or the film is also transparent, but it is extremely visible when the adhesive is pigmented, when the adhesive is formed with various shades like brown, green, red, etc. This is what I have seen in many places. One operator is engaged only for charging the adhesive, which can be avoided if we go for a simple system which was shown earlier. Adhesive craters or amoeba structures. The main reason for creating adhesive craters is dilution of adhesive with water, which one should avoid. Second reason is feeding of corner treatment level. There are chances that the corner treated film, if it is stored for some time, it can lead to a lot of problems while coating because the surface tension level of the film will be decreased and it will give rise to uncoated patches on the film. Uneven coating. The main reason for uneven coating could be the worn out rubber roll. The rubber roll surface is not uniform, which is going to give rise to uneven coating, uncoated patches, extra coating, etc. Misalignment or mismatching roller diameters, the roller widths, mismatching diameters of these rolls also create uneven coating. Uneven gap in the coating nip rolls will give rise to low coating on one side and excessive coating on the other side. The salvage group or the gauge variation in the film is also responsible for uneven coating. Misalignment of manpower and backup rule idlers is another reason for uneven coating. Faulty clutches, like typically the simple mechanical clutches, are the main reasons for the unevenness in the coating. Adhesive coat weight adjustment, lowering or increasing the coat weight. Coat weight adjustment by dilution of water should be totally avoided. And that too, many people they use tap water or hard water. It should be immediately stopped. Low release, roll unwind or their own. The main reason for this is adhesive coat weight is too low. Contamination of coated film with dust, old adhesive or the adhesive which has expired, too tight release, hence snapping while slitting or further processing. The main reason is faulty clutches, unwind tension or rewind tension, manual adjustment of clutches, Too tight rewind tension or too tight unwind tension. This will create unnecessary stress or stitching in the web or in the film. Idler rolls getting too dirty, adhesive deposition. Adhesive or printing ink deposition on idler rolls could be a major problem. No preventive maintenance at all, like no cleaning of the machine on a regular basis. This is how the uncoated patches or lines will show off in the finished roll like the figure shown on your right hand side. The reason for this could be mire bars not properly killed. Some adhesive particles might stick on or block some of the gaps in the mire bar. So the mire bar needs to be cleaned. It is most ideal to maintain a minimum stock of two mire bars of a particular diameter so that whenever you find a problem, you can stop the coating, change the mire bar, keep the mire bar for cleaning, and start the coating again. You all know that time is precious, but the material, the raw material cost, the manufacturing cost is even more precious and expensive. So it makes sense to correct the defect, stop the machine for a while, change the mire bar, and then continue. Contamination of foreign material in adhesive or in coating tray could be responsible for this. Improper cleaning of idler rolls will be responsible for this. Rubber rolls with uneven surface, dents, worn out patches will be another reason for this kind of problem like uncoated patches or lines. Material curl, it is related to tension, shrinkage, and moisture related problems. Dirty or contaminated idler rolls, too high tension at unwind or at rewind end, adhesive seepage through the backside due to mismatching rollers. You are going to see a figure or a picture shortly. Low drying temperatures could be responsible for improper drying, resulting into a wet adhesive, and this will result into transfer of adhesive to the rollers where it comes in contact, and that adhesive after drying is responsible for creating wrinkles, creating unwanted tension on the film and resulting into a lot of wastage. Very few or low air changes is another reason responsible for improper drying or keeping residual moisture in the coated film. Improper alignment of rollers and idlers is another reason. What I mean by mismatch rolls or the roll widths, here is the example. You can see the rubber roll here, which is responsible for picking up the adhesive from the gravure roll and apply on the film, is of 1080 width. The gravure roll has a working width of 1140. However, the substrate, the film, is of a width of 1020. So what happens due to this, there are chances that the adhesive on edges at the backside can be uh, coated because the adhesive might strike through the edges onto the backside. How it creates problems Let us have the next slide. Let us have a look. So, the above sketch will explain you how the adhesive is getting coated on the backside edges. This unwanted adhesive coated on the edges of the backside. As it travels, the uncoated the unwanted adhesive coated on edges of backside later on comes in contact with all the idler rolls in the drying tunnel as well as the other rolls. So how this can cause web handling problems you see here. Now it is quite visible at this point that the adhesive is coated on the backside. Now here you can see this is the dry adhesive. Here all the idlers which are coming in contact with the backside of the film, they get the unwanted adhesive deposited. As the adhesive dries up, it starts holding the film, and that is how the wrinkles are developed. That is how the film gets stretched. So the backside adhesive on the edges then starts sticking to each and every roller, idler roller, and is responsible for creating wrinkles, creases, and the web handling is more and more difficult. This results in poor quality of rewinding and the coated rolls with full uh, wrinkles, folds, and results into huge wastage and rejection. The entire machine idler rolls need to be stopped and cleaned thoroughly in this case. Now this is the wound roll. It is a perfect roll, but if the adhesive has been coated on the edges, then the adhesive on the edges will create heaps on the two edges, and that is why it could create a lot of problems. You can see the wrinkles created on the rewind roll because of the hips on the right hand and the left hand side of the coated roll. So the winding at the edges is very tight. The winding at the center portion is relatively uh, loose, and this creates problem while slitting these rolls on slitting machine. This is a perfect winding. The winding should be something like this. Now here you can see the coating side of a BOPP tape. Here you can see it from the another angle. This is how the housekeeping matters a lot. You see a very shabby kind of housekeeping here. The adhesive is spread out at many places. It not only results into a lot of wastage of adhesive, but it is many times responsive for small accidents on shop floor, like while adjusting. If the operator is in hurry, there are chances that he might slip and he might get severe injuries. So the handling of the adhesive, if we do it as per my suggestion which was shown earlier, this kind of problems will not arise at all. This is the common practice used as far as Indian tape manufacturers, BOP tape manufacturers are concerned. This should be avoided. There should be no charging of adhesive by hand, but it should be automatic as shown earlier. Now, the coated roll being processed on slitting machine. This is a perfectly wound roll. Now we'll come to another important section, that is the drying. Rejection in printed tapes, poor printing, mismatch in registration, ink transfer, all these matter or contribute to the rejection. Manual adjustment in registration because of the limitations of the printing machine or the coating machine, misaligned rollers, dirty idler rolls, printing ink deposition or adhesive deposition on idler rolls, too dilute printing ink, non-standard solvents or regenerated solvents are responsible for ink transfer or improper drying, resulting into rejections. Moisture-related uh, problems related to tunnels and wrinkles, improper exhaust or many times no exhaust system at all, diluted adhesive which results into higher percentage of water for evaporation results into lowering the speed, and if the speed is not lowered then there is residual moisture in the adhesive which is responsible for adhesive transfer. Extremely high gap between hot air nozzle air release points and the web supported with idler rolls, low ambient temperature especially in winter or rainy season. In rainy season, another problem associated is very high humidity in air. This problem is there in areas where the plants are situated near coastal areas where the humidity is always high. Improper air changing cycle, lack of fresh air inside the drying tunnel. Now, this is a figure which is showing the gap of the hot air nozzle shown in blue color and the web which is shown by black line and the idler rows which are shown in white color. The correct design or the correct gap could be approximately 12 millimeters between the web and the air nozzle. However, there are some machines where the gap is even more than 20 mm, or I have seen some machines where the gap is nearly up to 70-75 mm. If you have a design like this, you can imagine that the hot air, 50% of the hot air, it turns up and it is exhausted. So the actual hot air available for drying is minimized to a great extent, which results into the drying efficiency. Here is another design. Here you will see the gap between the hot air nozzle and the web is hardly 6 mm. This is also a wrong design considering that the hot air is blown at a speed of nearly 1500 cfm. At this amount of speed, if the gap between the nozzle and idler rolls is too low, there are chances that this air which is coming under force can disturb the wet coating on the film. The adhesive can be disturbed or the coating can be disturbed, which can result into many problems. Machine drying or the tunnel machine drying tunnel efficiency also depends on lower capacity hot air sources like low capacity hot air generator or thermopack, improper air distribution, absence of exhaust system, air leakages from the sides, from the windows, too large or too small drying tunnel, correct air velocity, lower capacity heating sources that we have already seen, improper air distribution. The air distribution nozzles play an important role in the drying process. Improper air distribution results in creating air pockets inside the tunnel, and that is how the drying efficiency is adversely affected. Have, have a look here. You see the type of nozzle which is shown in blue color. You can see the size variation is extremely on hazard. Some nozzles are very small in size, some of them are very big, and some of them are in between. But this creates a big problem like creating air pockets. The nozzles which are very close are going to disturb the wet coating. The nozzles which are very small in size are not able to deliver sufficient amount of air for evaporation. Absence of exhaust system. In some of the cheaper designs of drying tunnel, the exhaust system is missing. For efficient drying, the exhaust system is necessary just to replace the air inside the drying tunnel. The air with water or solvent vapor saturation needs to be replaced with fresh air so that more water or solvent vapor could be absorbed. In case if the exhaust system is missing, then the air inside the drying tunnel is always saturated and no fresh vapor can absorption can take place efficiently. Absence of exhaust system. Too large or too small drying tunnel. Now you can see this is insufficient area for proper air circulation because the tunnel size is too small. Too large area resulting into loss of heat and insufficient drying. Like this is an example. Correct air velocity also plays a very important role. Air at very high velocity can disturb the coated adhesive on the web when it is in wet condition, resulting into unwanted unevenness and lots of wastage or rejection. Now we will have a look at another crucial area of converting, that is slitting. Adhesive bubbles and blisters. These are seen mainly in the slit rolls, the air travel and the entrapment. Lack of absence of nip rolls is one of the reasons. This is how the air, a layer of air is always traveling along with the web. The air is entrapped near the rewind station. It gets entrapped between the two layers. One side is of course adhesive coated, the other side is the back side of the coated film. And because the adhesive is aggressive, the entrapped air sometimes doesn't find a way out, and this entrapped air results into air pockets. How does a winding lip reduce air wound into a roll? This is how we can install a, a surface drum or a nip roll which will help in dragging out the entrapped air just at the time of contact. Air is entered within the moving web's surface on both the entering web and the outside of the winding roll. The boundary layer of air travels at nearly the web speed. Without a winding nip, high velocity air creates high pressure at the web roll converge. An unnipped web, which creates only low pressure less than 1 psi, can be lifted by the air velocity pressure. A winding nip can create more than 100 psi pressure, opposing and compressing the entrant air pressure. Is entrapped air bad for roll quality? Here you can see a figure how the nip roll can help, and you can see various designs of the nip roll. Like a few examples are for shaft winding, direct shaft winding. Few examples are for surface winding. In both the cases, this is applicable. Not always air can be a great maker of capillary and diameter variations. However, if the air bleeds out over time, the roll layers will settle to a small diameter and loosen the roll. More air inside a roll will increase pump downtime for vacuum processes such as metallizing. Which is better, surface or center winding? Now here you see an example of center winding uh, in the top portion of the figure. At the bottom portion you will see there's a nip roll or the Leon roll, which will help in dragging the entrapped air. It's not about which is better, they both have important niches. As mentioned above, surface winding is good for rolls with large built-up ratios. Surface winding often can wind at lower tensions than center winding and exerts less torque on the building roll, avoiding torque-related clenching. Center winders have more automatic cut and transfer options. For many products, center winding is better for winding multiple rolls on a common shaft, especially with differential winding bars. How does a winding nip helps? You can see a figure here on your left hand side of the picture, the nipping roll, how it can help dragging out the entrapped air. The same thing is shown in the second figure. A winding nip, like most rolls, presents a uniform cylinder at the end of the span, therefore not inducting lateral tracking error. The winding nip then holds the web in place as it presses it onto the winding roll, ensuring a laterally aligned roll edges. The traction of the web to the winding nip holds the web in position, preventing web reaction to the airflow at the web roll converge. Do winding nips need to be cylindrical? Yes, winding nips should be true cylinders. Here is a picture of central surface winding with driven pressure roll or driven nip roll. How it helps, in removing the entrapped air. Should a winding nip be hard, metal, or compliant? A compliant winding nip is best since the compliant covering will reduce the cross-web nip pressure variation from roll diameter variations. An overlay hard winding nip roll may ride only on the higher diameter lines, creating stress concentration in the web. Can a spider rule be used as a winding nip? Here is an example of a tension rule as well as a nip rule. Since most spider rules are not cylindrical, they are not a good choice for winding nip. If you need to ensure lateral tightness at winding, use a spider rule just upstream of the winding nip. If the web is flat on the winding nip, it will be flat entering the roll. Will the winding nip promote a cylindrical roll shape? Have a look at the figure here. Yes, for many products, the winding nip pressure will compress the higher diameter area with higher speed winding. Winding nips will allow more air to wind into the low diameter areas. Both effects, both effects tend to improve roll cylindricity, which is very important for finishing. Surface air. All materials or coated films, they carry a surface layer of air. When the films are slit and rewound, the air is carried to the rewound roll. At low speeds, the layer of air can escape at the ends of the slit rolls without causing problems in winding. At high speed, air is wound into the roll. This can result in air acting as a